Hello, and welcome to VisML, a visualization tool for evaluating machine learning models. This tool was developed by PJ Allen, Juan Medina, and Zhujun Cheng with the support of our project mentor, Joshua Kraus. The data for this project was downloaded from the NYU Patient Viz GitHub repository and originates from healthdata.gov. More specifically, it is composed of a random 5% sample of Medicare beneficiaries and their claim data from 2008 to 2010. There are millions of records from inpatient claims, outpatient claims, carrier claims, prescription drug events, and beneficiary summary files. Once these features are binarized, the dataset grows to over 3,000 binary features. Our task was to build a tool that could be used to evaluate a model that was built to predict the occurrence of diabetes from the patient claim data. The model is a logistic regression model trained by the Clinical Machine Learning Research Group at NYU. The tool we designed has three components. In the center, you'll see a TSNE projection of the data. This is very useful for visualizing high-dimensional data as it reduces the features down to 2 dimensions based on patient similarity. On the left, there's a bar chart showing the distribution of the top 50 features as determined by their weights in the logistic regression model. On the right is a bar chart showing the distribution of outcomes, true positives, true negatives, and false negatives. Let's take a look at the tool itself in action. Right away, we can see that there are clusters of patients that form in the TSNE projection. If we take a look at these patient clusters, we can see how the features are distributed within them. By clicking and dragging over each cluster, we make a selection. And we can see that in these two clusters in particular, none of the top 50 features are expressed, and all of the points are true negatives and false negatives. Again, if we compare the middle cluster to the top cluster, we see that none of the top 50 features are expressed, and again, they are all true negatives and false negatives. We can also take a look at the outliers in this projection as they are preserved. We see them on the outskirts of these scatter plots. If we highlight one of the outliers and compare them to some of the others, we see that one feature in particular, diagnosis hierarchy 17, is expressed. And if we look at the outliers on the top, compare them to the same two on the right, we see again diagnosis hierarchy 17 and a new diagnosis that are expressed in those outliers. Interestingly, the outliers are all true negatives. We also notice that on the left side of the projection, we see all of the false positives are concentrated there, along with the true positives. And on the right, we see mostly true negatives and false negatives. It's a distinct difference between the two sides. And if we look, the feature distributions are different. On the left side, the first selection, or the gray bars, we see more occurrences of the top 50 features compared to the right side, which are the yellow bars that are much lower. The distribution of outcomes is somewhat similar, although again, we have mostly true positives and false positives. Most of those are on the left side of the projection. Thanks for taking a look at our tool.